this is a quick demonstration of the deltoid muscle and the neurovascular structures supplying the deltoid. So in front of me is the deltoid muscle. And we can see that the deltoid muscle has got three components. This first component, where my finger is located, this is the one which is arising from the clavicle, these fibers. This is the clavicular part. This middle portion is the one which is arising from the acromion, and this is the acromial part. And where my hand has gone behind, this portion, this is the one which arises from the spine of the scapula. This is the spinal part. These multipinnate fibers of the deltoid, all of them converge and they contribute to the bulk of the shoulder, the rounded appearance of the shoulder. And then they come down and they get inserted onto this bony projection on the lateral surface of the humerus, which is referred to as the deltoid tuberosity. So this is about the deltoid. The anterior set of fibers are responsible for forward movement of the hand when walking, and the posterior set of fibers, the so-called spinal fibers, they are responsible for backward movements of the hand when walking. And these two set of fibers, anterior and posterior, also act as stabilizing, or also known as guy ropes, to stabilize the shoulder joint in order to let the middle group of fibers, that is the acromial group of fibers, to enable them to do abduction of the arm from 15 to 90 degrees. Apart from these basic functions of the deltoid also acts as what is known as a shunt muscle. It resists inferior dislocation of the shoulder joint, which tends to occur especially when carrying heavy objects. The deltoid is a multipinnate muscle fiber, and it is capable of isometric contraction or isotonic concentric and isotonic eccentric contraction. The deltoid muscle is supplied by the axillary nerve, and in order to demonstrate the axillary nerve, we have split open the deltoid here, and I'm going to reflect it to show you the structures which are deep inside the deltoid. So we have separated the split deltoid, and we can see in front of us, this is the head of the humerus, this is the surgical neck of the humerus, and we can see running posterior to the surgical neck, around the surgical neck of the humerus, is this structure here, supplying the deltoid from deep inside. This is the axillary nerve. This axillary nerve, it goes through the quadrangular space. It winds around the surgical neck of humerus and it supplies the deltoid from its deep aspect. And after that, it pierces the deltoid and it supplies the skin in this region. The other structure that we see here is this. This is the posterior circumflex humeral artery, which is a branch of the third part of the axillary artery. This also accompanies the axillary nerve through the quadrangular space, and it is also ramifying inside under the deltoid, and it also anastomoses with this artery that we see here, which is the anterior circumflex humeral artery, which comes from the front, which is also a branch of the third part of the axillary artery. The clinical importance of this relationship, which I have demonstrated here, is that especially the axillary nerve, it is winding behind the surgical neck of humerus. So when there's a fracture of the surgical neck of humerus, the axillary nerve can be injured, leading to paralysis of the deltoid. Additionally, especially when the arm is abducted and if there's a blow from above, the shoulder can dislocate inferiorly, either inferiorly or anteroinferiorly. In either situation, it can compress on the axillary nerve in the quadrangular space, leading to paralysis of the axillary nerve, in which case there will be paralysis of the deltoid and there will be anesthesia here. And paralysis of the deltoid will lead to atrophy of the deltoid, and then the rounded appearance of the shoulder will be lost. And you will be able to see the acromion process and feel the acromion process very easily. That will be an indication that the deltoid is paralyzed.